There, I'm recording now. Apparently, I didn't realize that it was going to talk to me. That's fun. So I realized that yesterday and the day before, you guys kind of got the, it was a really bad situation, right? Because we didn't have class on, what was it, Tuesday? No, yeah. Monday, whatever. I missed you for a day, and then I was trying to get you caught up, and it just got all kind of blubbered, and it was icky. So I want to make up for that today with some practice. So that's like super not exciting. We're going to do lab tomorrow. It'll be way more fun than this, but I do want to make sure that you're really getting it and that you're there. I gave you a little piece of paper on your desk, and there's actually another one coming because it says, yes, there's more on the back. And then when I printed them, they all printed on one side, and I was saying really not nice things to the printer, but I didn't want to like reprint them because that seemed like even bigger a waste of paper. So, you know, you can use this to draw pictures on the back after. But right now I want you to look at the front. So we have talked a little bit about scientific notation. Yes or no? I don't even remember. Maybe not. So I want to just make sure that you understand what I mean when I say a scientific notation so that we're on the same page. I think that for most of you, this is some kind of review. But again, I want to kind of level the playing field, make sure that we're all on the same page. So I'm going to look at number one or letter A with you right now. So everybody's looking at this. Let's just take a glance. So it's 450,000 M for meters. That's 450,000 meters, but we don't want to write it with lots of zeros because my hand gets tired of writing zeros. So I can use my scientific notation skills and I can rewrite this. How do I do it? What do I do? Just the decimals. Yeah.
Change it to 4.5 times 10, and then you count how many over from the decimal it needs to go.
Love it. 4.5. So how did you decide that it was going to be 4.5 instead of 45?
Because you need one number in front of the decimal.
Right. Yep. So key things to remember there is that you want one digit in front of the decimal point. And can that digit be 0? No. So you want one, I'm going to put this in here a little bit more, one non-zero digit in front of the decimal point, right? And then you're going to move, so you move that decimal point over, so we're going to count 1, 2, 3, 4, 5. So we're going to write 4.5 times 10 to the 5th meters. How do you know that it's 5th as opposed to negative 5th, for example?
Because the zeros are behind it and not in front of it.
Boom, the zeros are behind it and not in front of it. So that means we're taking a big number, right? So we're going to have a positive exponent. If we start off with a big number, we're representing a big number. Another way to remember that, just little friendly reminders here, is that if you move the decimal to the left, the exponent is positive, okay? So you can write this down, you can have notes out, whatever is working for you to remember how to do this. Is that okay? Some of you are you're like, yes, let's do it. Do you want me to do one more with you, or you want to just do them? Just do them, yes. Oh, one more?
No.
I'm going to do one quietly up there so you can watch me. Everybody else can do them. If everybody at your table is done, then talk to each other and see if you've got them together so you can agree on them. We'll just double check. Does that sound good? So 0.23456445. My hand gets tired. So I'm going to count. 1, 2, 3, 4, 5, 6, 7. Did you get it? Yes! Awesome. That's fabulous. I'm excited for you. You're learning. Everybody's doing great. All right. So if you got A and B, check C and D with each other. See if you got them. All right. So if you got A and B, check C and D. How are we doing? Doing okay? So hopefully either this is a great review because you've done this before and it's coming back to me now, or I didn't learn this well before, I've never seen this before, and now this is making some sense. Is at least one of those two statements true? Okay. Can you tell me an answer for C?
8.007 times 10 to the negative 3. Oh, and the S thing.
The S thing. I love that. Seconds. Yeah. Do you guys agree with her? Fantastic. All right. And then D. Somebody else? What you got? Anybody? Anybody?
1.3 times 10 meters.
Love it.
Easy peasy.
Life is good? I love it. Excellent. Let's do something harder, shall we? Yes, please. All right. So I introduced you to these prefixes yesterday. I showed you this chart, right? And I said, I don't even know what I said. So I'm going to just tell you again what the story is. Do you have to have all of these memorized? No. Okay. I don't understand why we have to memorize stuff when we know where we can look for it, right? Okay. If you can Google it, then why have it stuck in your brain? Now that is true. But if you think about things in terms of time frame and how long it's going to take, if you don't have in your head that centa is 10 to the negative second, or that there are 100 centimeters in a meter, it's going to take so much time to look that up every time. You with me there? Okay. So that might be one that you want to stick into your head. So there are a few here. If you were writing something down to kind of keep this in mind, the ones that I would kind of make sure that you know are kilo, okay, which is 1,000, centa, which is 100th, milli. Those are like the three big ones. I would also encourage you to be familiar with micro and nano because we use those a decent amount in physics as well. Okay. We're going to did we do any of the conversion practice last time? I can't remember. Or it was just time to go. The bell rang and told us it was time for us to be done. So hold on. I'm going to see if I can select this. See if I can do that well. Sweet. I don't know if that'll work. Let's find out. I don't think it's going to. I'm not feeling very positive about this. Paste. Nope, that didn't work. Wah, wah. It's getting overly optimistic, but I kind of think that maybe I still have it there. That's what I really want. Let's copy that and paste that. There it is. That's what I wanted to see. Okay, so let's do a couple practices. We're going to do a couple easy practice first, and then I'll give you some harder practice on another little sheet that was supposed to be on the back of the sheet that you have. But now it's convenient because you can do those on the back. So you're welcome. I did that on not purpose, but we'll pretend. All right, here we go. I threw kind of not a hard one, but kind of a funny one in to start. 7 what? Micrometers? Yeah, it's not Do you know what letter this is actually? Anybody know? It's up there. Do you know what that orange stuff is up there? You may have seen it when you're driving around Iowa City outside of houses, kind of downtown. Greek alphabet. It is. It's the Greek alphabet. Yep. So you are familiar, if we just look up there, you're familiar maybe with a few of these, like, oh, this one that's next to the big P. You know pi, I hope. If you don't, we have some talking to do. You probably know this one that's next to the thing that's like an I. Theta, right? You've seen theta before. What else have you seen before? Maybe delta. Yeah. So these are just other letters, right? You know, and we'll get to know a few of them as the year goes. This one right here, I'll tell you what it's called. It's kind of fun. It's called mu. Mu. That's what the letter is called. Yeah, it's just kind of a cute, it's kind of like the sound that a cat makes. Mew. Like that's kind of what that's how one remembers it. Anyway, that's just random trivia for us right now, because all we really need to know is what mu means or what micro means. So here we go. I want to convert 7 micrometers into meters. Here we go, friends. We're going to write 7. Instead of writing micro, I'm going to translate it. 10 to the negative 6th. Then I've got my meters. Are you with me there? Let me show you what I did again. So I had 7 micrometers, and literally what I did was that I changed the micro to 10 to the negative 6th. I'm just translating. It's kind of like when you're translating something from English into Spanish, okay? Or from one language to another. Like literally that's what you're doing. Micro is 10 to the negative 6th. Boom, you're done. Is that okay? Okay. Do you want to try B over here? Sure thing, Miss Carveling. That sounds great. 93 kilometers, kilometers. So we're going to look and see where kilo is. Oh, it's right there. Kilo means 10 to the third. So instead of writing the K, you're going to write 10 to the third. 93 times 10 to the third meters. Now that little red flag in your brain might be going off right now. Why? Yeah. Because it's not technically a scientific notation, right? The decimal is behind the 3. So you could then move this one over. We're going to move it over 1 to the left. So what does that do to this 3? Makes it a 4. It bounces it up, right? So this is really going to be 9.3 times 10 to the 4th meters. How are we doing? Yeah.
I have a question. So, you know how it says like kilometers? So like you only worry about like the K, like you did the U, and then the M is just like meters.
Right.
And then like number C would just be like seconds.
Yes.
Okay.
Yes. So the base units, I thought we did this yesterday, but we may not have. And even if we did, it's totally fine that you're asking again. I want to make that really clear. So the base units that we're shooting for, did we do this yesterday or no? Oh my gosh, you guys. You're such troopers. I appreciate your effort and your patience with me. Base units. Base units. SI base units. That's what we call them sometimes. Scientific International, right? We're measuring lengths. What do we measure lengths in? In meters. What do we measure time in? Seconds. What do we measure mass in? Got to be careful because we're not in chemistry anymore, right? It's weird, right? I love that face. She's like, what? If you walk across the hall and you talk to the chemistry teachers and you ask them for their list of base units, and they're probably teaching the same stuff right now or maybe next week or something like that, right? They're going to tell you that length is measured in meters and time is measured in seconds, but we don't do time a lot, so they probably don't pay attention to it a lot. And then when they say mass, they're going to say what? Grams. But then here, I'm telling you to ignore that, wipe that from your memory, because in physics, we always use kilograms. That's weird. Why do we do that? The answer is not to just make enemies with the chemists. Why would we do that? Any idea? Why do the chemists use grams and we use kilograms? What's that?
They're measuring is small.
Generally, what they're measuring is a lot smaller, right? You're taking just a couple of grams of this and you're, combining that with, you know what I'm saying? Like, they're looking at things that are really small, whereas we're looking at tennis balls falling and cars that are riding and all that kind of stuff, things that are bigger, that are on the order of kilograms. You've got these weight sets in front of you, except for my friends over here, because I only got enough out for the last period, so you can share. But the weight sets in front of you, if you look at that big one, that's a kilogram, okay? That's our base unit, that big one. So you can feel it. Take it out, pass it around. You can feel how heavy it is, okay? It's not super light, but that's kind of our base unit. So when we're rolling balls down ramps, we're talking about things in terms of that. If you take the little tiniest one, you can take a look at what the label is on that one, okay? It's 10 grams, so it's like a lot smaller, right? We're talking about a tenth of that. My friends over here, I'm not going to show it because that would be. But I mean, compared to like some, right? Yeah. I've got a pretty good arm too, so I don't know. Like, yeah. Oop! Whoa. All right. So, just to kind of bring this all together here, that kilogram, even though, and this is the weird thing, is that our base units usually don't have a prefix, except mass. Even though in physics, we deal with big stuff like black holes and stars, right? And we also deal with things that are smaller than protons and neutrons. right? We look at the things inside protons and neutrons. Did you know there's stuff inside a proton and neutron? There is. They're not the smallest things. What? That's weird. So we find the masses of those things, but even when we find the mass of something smaller than a proton, we still write it down in terms of kilograms. It's weird. It's just 10 to the negative a lot of kilograms. Does that kind of help with your question?
It does.
Awesome. I probably told you way more than you really wanted to know, but it got me started in that way, so I appreciate that. All right. Can you do C by yourself? Do it. If you haven't done it already, go ahead and do it right now. Write it down on your paper. Go, go, go. C. And you can talk to each other. It's absolutely fine. I would say, unless I've told you otherwise, please talk. How do we do? Here, I'm gonna take this one step at a time, just to not freak people out. 17.2 times 10 to the negative third. Or, no, hold on, just a second, because you might not. Yeah, let's take it a step at a time. 17.2 times 10 to the negative third seconds. Is that okay so far? So far, so good. Okay. So then, are we in scientific notation? No. Not quite. I mean, it looks kind of scientific notation-esque. But there are 2 digits before the decimal, right? It's going to move this guy over. Now, what's going to happen when I move it? Right? This is why I like this question. Let's take a look at this one right up here. Let's look at B. Stay up here with me, you guys, because this is where I don't want you to get caught off guard and get it in a funny way. You had 93 and you moved it over and you moved this from a 3 to a 4, so you went up, right? Here you're moving from 17 to 1.7, so you need to move this up. What does moving up 1 from negative 3 mean? Negative 2. With me there? Okay. So I just don't want you to get stuck in a funny spot where you're like, I got this, and then I make a silly mistake. Fantastic. Help me out with this next one. What's that up? What's up with that? We're in grams, we're converting to kilograms. This is a different game, right? In these first 3, for my friends that are not as familiar with this, let me just review what we did. We translated the prefix into a 10 to the whatever. Okay, we just literally translated it. In these 2 down here, though, we're trying to add a prefix. Do you see that? Like here, we're going to try to add that kilo. Let's think about it this way. If I have 27 grams of something, am I going to have more kilograms or fewer kilograms? Fewer? Yeah. This says 10 to the third. That would be big, right? I'm trying to make it fewer. So there are different ways to look at this. I'm going to do it this way. 27 grams. Do you know what part of multiplication I like the best? Multiplying by 1. Who likes to multiply by 1? Everybody does, right? Like when you were learning how to multiply in 2nd grade or 3rd grade or whenever that happened, and you had to learn the times tables. Do they still do that? You have to learn your multiplication facts. Yeah. And you the flashcards, and then it's 3 times 7. You have to think of it, and then you get 4 times 1, and you're like, sweet, I got that without even thinking, right? Because 4 times 1 is just 4. And then your dad is trying to trick you, and he's like, okay, what's 1,000,000 times 1? You're like, oh my gosh, and then you're like, oh wait, it's just 1,000,000, right? It's 1,000,000 times 1 is just 1,000,000. Multiplying by 1 is just the nicest thing ever. I want to convert from grams to kilograms. Hey, this tells me what it is. From grams to kilograms. Kilograms, there are 1,000 grams in a kilogram. Are you with me there? There are 1,000 grams in a kilogram. I'm going to write 1 kilogram up here. I'm going to write 1,000 grams down there. How are we doing? Are you okay so far? Why do I do this? Because this fraction is equal to 1. These 2 things are equal. If I have grams on the top and grams on the bottom, those grams get to go away. See you later. 27 divided by 1,000. move it that way. So that's 27 times 10 to the negative 3 kilograms. That's the long version. Can I tell you the short version? You don't really have to think very hard, but just kind of know it version. This one always breaks my heart a little bit because I feel like I'm cheating, but I do want to tell you because it's easy. If you add the prefix, you also add the opposite of what it means. So this says 10 to the third. I'm going to make it 10 to the negative third. Are you with me there? Does that make sense? It's kind of sneaky. I feel a little like tricky doing that, but I'm just going to tell you anyway. Okay? So here's the rule for up here. If you add a prefix, also add the opposite exponent in the times 10 to the whatever. The fill in this blank here. Is that okay? That's the like sneaky way to do it. Do you think you can do E? You have to do both things for E. You have to go from milligrams to grams and then grams to kilograms. That's like the ultimate. I will tell you guys one of the things I love when I'm teaching this stuff, if you can do the super hard one, then you can do anything. But you can do the super hard one. I want you to give it a shot. Talk to your table mates, help each other out, work together, see if you can figure it out. Well, I'll go through it with you in a minute too, but I want you to see if you can do it. Give it a try. Here, you probably need that chart though, don't you? I'll just leave it like that for now. What's your question? Oh, because I told you.
Oh, okay. Okay.
Yeah,
I thought I was wrong. Okay.
No. That would not be fun.
Okay.
I just
Okay.
want to leave that distracted.
Okay. So you have to go.
2.7 times 10 to the negative 2.
Okay.
Yeah, no, you're right. I often will get distracted. I'm like, I got it. Except it's not quite done. So yeah.
Right. So how many milligrams?
Is this stuff making sense? Like, is this super news a while ago? I know. What? Did you get this from last week? Oh, yeah. You were working on it? You posted your questions, okay? Yeah. That's so you moved it this way? Yeah. So then you're going to one of those back. Like this is kind of either coming back or
It's like milligrams.
Yeah. So
I don't know.
and you can say this sucks and I don't understand anything. That's totally fine. You once you get it to grams, then you can.
Okay, so
You can only do that once you got it.
then we have to like divide that.
Which part? To get to the kilograms?
Yeah.
So I would convert it to grams first. So 0.33 times 10 to the negative 3 grams. Does that make sense? Yes. This is just like a three-filled problem. I do not have the accident of consequences. Correct. Then you can use the little sheet.
But if it's positive, then you go for.
Are you planning to? Yes. Yes, I like to. Yeah, that's okay. It says Manila at the bottom. Yes. Yeah. Yes. So we would say, depends on how you said, how many grams?
Or you would add it to be.
So you say 1,000 kilograms. Yes. Sorry.
Oh, because the sign
I
changes. So it's
Right.
right. Oh, it's like positive. Yeah, the negative.
Well, it should be further away than.
Here.
So there's three different milligram, gram.
I think
And you should be able to further away.
Yes, and then you convert that, because that's the reason we got that. I think
Because the
you
sign.
got it.
So if you already have that. And you're adding the sign change to the 10%, you're adding that.
So I do a lot of like switching. No, I love it. Yeah. Love it. All right, team, how are we doing? Did we come up with an answer? Did you come up with an answer or no? Yeah? No? Yeah? Do you want me to walk through it? Yes? Cool. I'll do it. 0.33 times 10 to the negative third grams. Is that okay? First step. So for those of you that are not completely sure, I'm just kind of walking through this. So I have 0.33 milligrams. So that's going to be 0.33. I'm translating my milli to 10 to the negative third grams. So far, so good? Okay. So now I need to get to kilo. So now I can use the cheating box if I want, or you can do the division. I want to be really, really clear. On a lot of things in physics, there are multiple ways to approach a problem, multiple correct ways, I should say, to approach a problem. If I don't do it exactly the same way you do, but we get to the same path and you have good reasoning for what you're doing, that's fine. You do not have to do it the same way I do. Some of you have done this in chemistry or in math or whatever, and so you know these other ways to structure it. Awesome. Do it. Don't relearn it just for me. Okay? I'm just showing you one approach. So I just want to make that really clear. All right. So I'm going to do this little funky box method. I like the term funky box. So now I'm going to say that this is 0.33 times 10 to the negative third. So that's what I had originally. I'm going to add another times 10 to the negative third kilograms. So I just added this little piece here, right? Same as I did up here. How are we doing? Are we okay there? Okay, so I just added this. Now I have to put this stuff together because this is a disaster of an answer. Would you agree? Like if you wrote this down, I'd be like maybe simplify a little bit here. So let's simplify. Here we go. So I'm going to go ahead and leave it as 0.33 for now. Some of you are like, that's driving you bananas, and I'll get there. We'll fix that. I promise. Okay, Sam, don't think I'm going to forget this forever. Because you called me on that one. That's what I'm just saying. Yeah. If I've got two things that I'm multiplying together, what do I do with the exponents? Add them. Absolutely. So I'm going to say times 10 to the negative 3 plus negative 3 gives me negative. You got it? So I'm almost there. Now I've got to move this over, right? Or Yeah, move it over right. Ah. You guys with me? Did you catch that? Yeah? Awesome. So 3.3 times 10 to the, what's going to happen? 7? Okay. Listen really carefully.